Okay, today we're going to review.
Staying with
Today we're going to review absolute value equations and some other like square root type equations and rational equations. Tomorrow we're going to do inequalities. So, do you remember what absolute value is? Absolute value is, it's the distance a number is from zero. It's the number of units. So, do you recall from Algebra 1 how to solve an equation like this? It says the absolute value minus 4, and I'm going to write it over here. Absolute value minus 4 of x minus 4 is equal to 8. Okay? So, how do you solve this? First of all, do you remember what kind of number this has to be? Positive. If this were a negative number right here, can you take the absolute value of a number and it ever equal a negative? No, so it'd be a no solution. So how do you go about doing this problem? Do you remember? Break it up into two. Do you remember what they are?
Isn't it actually x minus 4 equals 8 and that is a, and you do x minus 4 equals negative 8?
Yeah,
X plus 4
exactly. Exactly. You do both of these problems. So you do the positive 8 and the negative 8. Now you're going to add 4 to both sides on this side. And you're going to add 4 here, and you're going to get x is 12. So let's take a look at these. Why are there two answers? Well, because 12 minus 4, the absolute value of that, which is 8, is 8. And negative 4 minus 4, which is negative 8, the absolute value of negative 8 is 8. So these two answers both work. Now, if we were to graph the solution, here's the graph of the solution. So 12 is a solution, and so is negative 4. These two are solutions. Now, if you notice, the halfway number between these two, to get equal units apart from each other, so to get 8 units away from the middle number is negative 4. See, that's where the negative 4 shows up. So you take it's the difference. Okay, so some number minus 4, that middle number, is equal to 8 units. So 8 units this way and 8 units that way results in these two numbers, 12 and negative 4. So this is where 8 units is, 8 units here, and negative 4 shows up right there. So this is a positive 4, but it's the difference. Okay? So, how do you do these ones where we have, these get you're going to notice that in this section, they're going to get a little bit more difficult as we move along. So we have now the absolute value of x plus 4 equals 5x minus 2. When you start introducing variables on both sides like this, you are now introducing a possibility of an extraneous solution, where you get an answer that looks like it's true, but when you substitute it by checking, it doesn't work. It's extraneous. So what you're going to do for this problem is you're going to start off by saying, okay, let's do two problems. We're going to break it up into x plus 4 equals 5x minus 2. And all I simply did was drop the absolute value bar. And what would the other problem be? X plus 4 equals, anyone know what the other side's going to be?
Negative 5x.
Very good, negative 5x plus 2. So when we solve both of these, I would add 5x here. So I get 6x plus 4 equals 2, subtract 4, 6x equals negative 2, divide by 6, and you're going to get negative 1/3 when you reduce it. Well, after putting this number in here, I know common sense it's not going to work. First of all, when I put any number within the absolute values, when you take the absolute value of it, it comes out what? Positive or negative? Positive, right? Any absolute value. You can do negative 1,000,000, and the absolute value of negative 1,000,000 is 1,000,000. You could take negative 0.00000, it's gonna come out positive. But what's gonna happen over here, when you do 5 times negative a third, you're gonna get a negative number, minus 2 is another negative. So a positive number can never equal a negative number. So this is an example of an extraneous solution. Let's try this side. We would subtract x. You get 4 equals 4x minus 2. Add 2, you get 6. And divide by 4. And you end up with 3 halves. 6 over 4 is 3 over 2, or 1.5. Now if you plug that number in here, it works. So if you did 1.5, what is 1.5 plus 4? 1.5 plus 4 is 5.5. The absolute value of 5.5 is 5.5. Does this equal? You're going to do 5 times 1.5. Let's do that. So what's 5? 5 times 1.5. 7.5 minus 2 is 5.5. So does 5.5 equal 5.5? It sure does. So that is a check for your answer. Now, what happens, what do you think you're going to do in this problem? This is not normally what you've seen in the past, having an absolute value with a quadratic inside of it. But what do you think you should do? The same thing you've been doing all along. You're going to break this up into 2 problems. What would be your 2 problems? What are the 2 problems? You're going to break it, split it up into 2. What are the 2? One of them is x squared plus 4x minus 3 equals 2. And the other one would be x squared plus 4x minus 3 equals negative 2. So you just do a positive 2 and a negative 2. So when they're quadratics, when the degree is a 2, we spent the entire day yesterday reviewing different ways to solve these. How would you solve this one? We're going to subtract 2. Get a 0 on one side and try to factor this. Can you factor this? What do you get?
It's
so
so
what-
right now.
I gotcha. So your 2 answers are negative 5 and 1. Are those the only 2 answers? Gotta do this side. We're gonna add 2. You're not gonna like this side. Can you factor this one? We have to do something else. For this one, a lot of people want to do you're so comfortable with quadratic. Let's do something we're not as comfortable with. How about complete the square? This one's a good one for completing the square because of the 4 here. When this is an even number and the leading coefficient is 1, this is super easy to complete the square. Watch how easy it is. We're going to bring negative 1 to the other side. Half of 4 is 2, and when you square it, you get 4. You're going to factor this. Then you're going to take the square root of both sides. And you get x plus 2 equals plus or minus the square root of 5. And then slide 2 over, and your answers are negative 2 plus or minus root 5. Already simplified for you. So there's 4 answers. Next. How do you solve a radical equation? What would be your first step? Take a look at this. We're trying to solve for x. What should we do?
5 over 3 is
I would subtract 5 as well. Okay, next. Square both sides. Excellent. Now, this is the trouble. You have to square that binomial. The left side you guys don't have problems with. You know that the square root of 3x minus 11 is 3x squared is 3x minus 11. But it's this side. Do you guys, please you don't square these individually. This is not a product. You have to square them as a binomial. So what you want to do is x minus 5 times x minus 5, which means you have to FOIL this. You end up with x squared minus 10x plus 25. Does everybody understand? Watch this. Okay, now what should you do? Because it's a quadratic. What should you do? You've got to move, you've got to zero one side out. Which is the easiest side to zero out? Yeah. So let's get rid of these two. Can I do them in one shot like that for you? Subtract 3x and add 11. So you end up with your 0 on the left, and you get x squared minus 13x plus 36. Can anyone think of a way to simply factor this quadratic? What's the simple factors of this? X and x, -9 and -4. And you get 9 and 4. Now, because of the variables on both sides, you have to check your answer. And I can tell you right now, 4 doesn't work. Because 4 minus 5 is going to give you a -1. And when you take the square root, you're not going to take the square root of something and get a negative. So this one's actually extraneous right here. This one's extraneous. The other one works, 9 works. So 9 works. Anybody have any questions on that one? This one is probably your least favorite, where you have to square this problem throughout. You have to do the squaring process twice. What should you first do when you have two radicals on one side? One of them's got to go on the other side. Which of these two makes most sense to move? The one with the negative, right? So if we separate them, I get 2 plus the square root of x plus 7, right? Now you guys know we have to square both sides. The left side is a piece of cake, 2x minus 3. It's the right side that's going to give us some trouble, how to square that. Do you guys know the fast way how to square it? You square the first term. What's 2 squared? Then you take these two and multiply them, and then multiply it by 2. So you get 4 times the square root of x plus 7. And if you don't know the fast way, you should, double it up and FOIL it out. And then then you square the last term, and you just get x plus 7. Now, I'm stuck with a radical still. So what I have to, your job is to get this by itself. So you want to move these 3. Get these 3 out of here. Get them over there. So you can square both sides. You don't want to square both sides right now. That would be a disaster to do this. So get the 4 out of there, the 7. Can you add 4 and 7 and get 11? And then subtract 11. Can you do that all in one shot? So 4 and 7 is 11. So subtract 11. So those are gone. And then subtract x. Everybody see what I did? So you have 1x minus 14 equals 4 root x plus 7. Now what? Now we get to square both sides again. When we square the left side, we end up with x squared minus 28x plus 196 equals Who can tell me what you get on the right side when you square this? We have to square this, and then we have to square this. So what do you get? Do you get 8 or 16? 16, good. And then x plus 7. Now what? Distribute, I heard. Distribute what?
The 16.
It's 112. Next. Then what?
The 16x.
Get a 0 on one side. So we're going to subtract 16x and 112. You end up with, when you do the subtraction, I'll write it up here because I'm running out of room. You have x squared minus 28x plus 196. That's what we had. So you're going to subtract 16x. It's 44, minus 44x. And then we're going to subtract 112. And we get 84. Now, can anyone think of how to factor these two? Or factor these three? I know x and x. 42 and 2 are both negative. So the two answers are 42 and 2. And looking at my solution, one of them is extraneous. Sometimes they both work. Sometimes both of them don't work. Anyone know which one doesn't work? Well, let's do it. Let's try 42 in here. If we were to put a 42 inside, we have 2 times 42 minus 3 minus 42 plus 7. Does this equal 2? Well, we have 48. No, not 48, 84. 84 minus 3 minus, and this is going to be 49. Okay, so this is 81. What's the square root of 81? What's the square root of 49? Does 9 minus 7 give you 2? Yep, so that one worked. So let's try 2. What's 2 times 2? 4. What's 4 minus 3? What's the square root of 1? 1. Minus. And what's 2 plus 7 is 9. What's the square root of 9? Does 1 minus 3 give you 2? No. So this one was extraneous. That one's extraneous. This one works. Okay, the next example is a rational equation. It's rational. What you're going to want to do on these ones is factor the numerator and factor the denominator the best you can. In both of these, they're both simply factorable. How do you factor that numerator? It's not one of your favorite ones to factor, but we can factor 6x squared minus 1x minus 1. Think of numbers that multiply to give you 6 that are close together because you have a negative 1 here. Would you use 6 and 1? No. You're going to use 3 and 2. Now, you don't have many choices for 1. 1 times 1 is 1, right? But one of them has to be negative and one has to be positive because it's a negative 1. Where do you put the negative and where do you put the positive? Should I put the negative here? This one? Here? Yep. Because you want a negative 3x and a positive 1x, which gives you a negative 1x. You're right. How about the bottom one? How do you factor 2x squared plus 9x minus 5? For 2x, you don't have much choice. And for 5, you don't have much choice. But I need to position them so that I get a 9. And I need a negative 5. So one has to be positive, one has to be negative. That works, because this is going to give me 10x. Just put a positive here and then the negative here. Do you see something the same?
2x minus 4.
Yep, these are going to cancel, so cancel them out like that. So now what you have here is 3x plus 1 over x plus 5. Set this equal to 0. When you have a fraction equaling 0, the numerator must be a 0. This must be equal 0. So what you do to solve this one now is you set x plus 1 equals 0. And what would x have to be to get a 0 in the numerator? Anyone know? Subtract 1 divided by 3? Negative 1/3. If x were negative 1/3, if you put a negative 1/3 right here, what's 3 times negative 1/3? Is negative 1. What's negative 1 plus 1? 0. So the value that gives this fraction equaling 0, make it work, is when x is negative 1/3. Okay? So let's say we had a problem. I'll make it a little easier. What if I gave you x squared minus 5x plus 6 over x squared minus 4? I don't know why I put parentheses. And set this equal to 0. How do you factor? This is on a lighter note. How do you do this one? I want the zeros for this. How do you factor that numerator? How do you factor the bottom? Then what? Cancel those. So now, what you're left here is this fraction. So how do you get this fraction equaling 0? What would x have to be? 3. Now, you don't want a 0 down here, because if you get a 0 down in the bottom, it's undefined, right? So I want a 0, and the only way to get this fraction equaling 0 is when x would be 3. Last problem. These are the last 3 on your assignment for today. These are called literal equations. A literal equation is like an equation like perimeter is equal to 2L plus 2W. Well, sometimes we don't want to know what the perimeter of something is. We might know the perimeter and we want to find the length of a room. So you remember how to solve for like L in this problem? What would you do? Minus 2W. And then divide by 2. Remember this? Well, in pre-calc, the literal equations get a little crazy, like this one. Now we're testing to see, can you get G by itself? This says capital T is equal to 2 pi times the square root of m over G. I want you to solve this for G. So do you know the steps to solve for G? What would you do first? What's that? Divide by 2 pi. So does everybody agree that T over 2 pi is equal to the square root of m over G? Then what? I've got a radical stopping me. So you're going to square both sides. When you square the left side, what do you get? T squared is correct. That's it? Just T squared? Over 4 pi squared. You have to square everything. And then you get m over G. Now what I would do is I would cross multiply. because you want to get g out of here. So if you multiply these two, you get t squared g equals 4 pi squared m. Now how do I isolate g? Divide both sides by? Remember this? And that concludes your notes for today. Are you okay? Can you hit